It is known that many factors influence diet and food consumption, such as portion control and serving sizes, visibility and convenience, accessibility and availability in food retail, activities, hormones, and social influences. This study was conducted to better understand the influence of inhibitory control on diet and food consumption. This study is important because it helps to build a better understanding of the lesser understood impact of inhibitory control on diet and food consumption. Researchers were not aware of any studies that related directly to ERP indices of inhibitory control to food intake in either controlled or naturalistic settings. The researchers hypothesized that inhibiting responses toward high-calorie food fixtures would elicit larger or more negative N2 amplitudes compared to low-calorie foods. The researchers also tested competing hypotheses that either individuals with larger N2 amplitudes are less efficient at resisting environmental food cues and will eat more, or individuals with larger N2 amplitudes are more successful at resisting environmental food cues and will eat less.
Participants were recruited from posted flyers and from classes that offered credit. All participants spoke English as a first language, had good mental health, and no chronic or metabolic disease. Participants were excluded if they used recreational drugs, were pregnant or lactating, or had lost consciousness due to head injury. In total, 159 participants participated in the study. To control for confounding effects like sleep, participants were told to get at least 7 hours of sleep the night before, and to abstain from strenuous physical activity and drinking caffeine for 24 hours before the study. To control for hunger effects, participants were asked to stop eating and drinking by 9 the night before, for those in the day study and 4 hours prior for those participating in the evening study. Controlling for those effects allowed researchers to look at neural responses to food cues when participants were about to eat their next meal. Fasting allowed for control over calorie intake, which may influence neural response to food cues. If participants did not complete the requirements, they were rescheduled to participate at a different time. Participants then completed a demographic survey, the Dutch Behavior Survey, and the General Food Craving Questionnaire. Hunger was measured using 6 visual analog scale items. They were also asked to complete an online dietary recall for a minimum of 4 times. Once during the lab session for the prior day, one for the lab day, one randomly assigned weekday, and one randomly assigned weekend. They were only required to record an extra day if the recording did not comply with their resting metabolic rate. After completion of questionnaires, participants completed a 2 go-no-go task while wearing an EEG sensor net. These tasks were used in order to produce the N2 ERP component and assesses inhibitory control towards low and high calorie foods. N2 amplitudes were collected to see if they predicted calorie intake. To test the hypothesis that indications of inhibitory control are different between high and low calorie food stimuli, a 2x2 repeated measure was performed. During the high calorie task, high calorie foods served as a no-go stimuli and low calorie foods served as a go stimuli. Participants were asked to press a button when they saw pictures of low calorie foods and refrain from pressing the button when they were presented with pictures of high calorie foods. Participants were asked to do the opposite during low-calorie tasks. They were to push the button when they saw pictures of high-calorie foods and refrain when presented with low-calorie foods. The low-calorie food images consisted of vegetable and fruits. The high-calorie food images consisted of desserts and high-calorie meals for breakfast and dinner, such as hamburgers and waffles. Pictures were presented for 500 milliseconds with a random stimulus in between.
Researchers found a main effect for trial type, with no-go trials eliciting a larger or more negative N2 amplitude than go trials collapsed across the high and low-calorie tasks. There was no main effect for high versus low-calorie tasks collapsed across go and no-go trial types. Post-hoc paired samples t-tests revealed that no-go N2 amplitude was more negative during the high-calorie task than during the low-calorie task. Go N2 amplitude was more negative during the low-calorie task than the high-calorie task. In addition, no-go N2 amplitude was more negative than go N2 amplitude during the high-calorie task, whereas go N2 amplitude was more negative than no-go N2 amplitude during the low-calorie task. Inhibiting responses toward high-calorie foods on the high-calorie task elicited a larger inhibitory response, as indicated by a larger no-go N2 amplitude. However, inhibiting responses toward low-calorie foods on the low-calorie task did not elicit an inhibitory response, as indicated by a smaller no-go N2 amplitude. There was also a main effect for trial type as expected. In other words, individuals were more accurate on go trials than no-go trials, collapsed across high and low-calorie tasks. Additionally, there was a main effect of task, with individuals being more accurate on the high-calorie task than low-calorie task, collapsed across trial type. Overall, individuals were more accurate when having to inhibit responses toward high-calorie food cues, but were slower when having to respond toward high-calorie food cues. The result of hypothesis 2 was that age and BMI did not significantly predict caloric intake. However, sex did predict caloric intake, with females consuming fewer calories than males. In addition, high-calorie N2 difference amplitude predicted caloric intake, where individuals with more negative N2 difference amplitudes consumed fewer calories. Sex also predicted carbohydrate intake, protein intake, and fat intake, and that females consumed less carbohydrates, proteins, and fats than males.
The results supported the researchers' first hypothesis that there would be a larger inhibitory response to high-calorie foods. During the high-calorie task, subjects had larger N2 amplitudes and increased accuracy when inhibiting responses towards high-calorie foods than compared to low-calorie tasks. These results support the hypothesis that correctly responding to high-calorie foods requires increased recruitment of inhibitory control processes, possibly due to more appetizing high-calorie foods. Participants had longer reaction times when responding to high-calorie foods than reacting to low-calorie foods, suggesting that increased recruitment of cognitive resources when processing high-calorie foods not only aids individuals in being more accurate, but may also help them manage their increased attention towards high-calorie foods. Participants took longer to respond to high-calorie foods, but had better accuracy. Research suggests that this is because inhibiting towards high-calorie foods compared to low-calorie foods is more demanding, and so in order for the participant to be more accurate, they must slow down, but future research is needed to be done to support this idea. Inhibiting responses towards high-calorie stimuli on the high-calorie task produce a greater no-go N2 amplitude compared to go trials. Inhibiting responses towards low-calorie stimuli on the low-calorie task cause a smaller no-go N2 amplitude compared to go trials. This suggests that because high-calorie foods are more appetizing, they might impact why the brain recruits more cognitive properties to suppress automatic response from high-calorie food. Researchers propose that the high-calorie task might be a more valid measure of food-related hesitation because only the N2 amplitudes difference predicted a caloric intake and the low-calorie N2 difference did not. Results indicate that the brain may process low and high-calorie foods differently. Just by switching high and low-calorie foods as no-go stimuli, a change in neural responses was seen. In order to get a better understanding about how the brain processes these food cues differently, future studies should look at to see if these ratings of tastiness affects inhibitory control. This study is new and unique, with only one other study found by the researchers that examines the inhibitory control difference between high and low caloric food stimuli. However, this study had a sample composed of adolescents and young adults. The study's participants were older, with an age range from 18 to 55. Its main effects were motivated by inhibiting to high-calorie foods, but this was not the case in the other study, where no differences between the food stimuli were found. The varying results between the two studies could be due to the age and developmental differences. Frontal brain regions involved in inhibited control process are not fully developed in adolescents. When testing for hypothesis 2, subjects with larger high-calorie N difference amplitudes ate fewer calories, suggesting that inhibitory control, specifically to high-calorie foods compared to food in general, may help regulate food consumption and eating habits. Larger high-calorie N2 difference amplitudes predicted less consumption of carbohydrates, but this prediction did not apply to proteins or fats. Intervention should focus on controlling the urge to eat foods that are high in calories, but specifically carbohydrates. Managing this may improve eating habits and practice regulating food. In a previous study, it was found that inhibiting responses to food stimuli versus neutral pictures produced a larger N2 amplitude in females and not males. This study controlled for sex and found that although sexes affect eating habits, directly inhibiting control processes may still help manage food intake and eating behaviors regardless of gender. This study is the first to focus on the relationship between food intake and neural indicators, and the results should be taken with caution. Researchers recommend that future studies replicate using the N2 amplitude. This study has a few limitations. Self-reports were used to measure the participants' craving and eating, but results suggest that these may have not been as accurate as objective measures when looking at inhibitory control. It is recommended that future studies use objective measures such as weighed food buffets or taste tests to more efficiently measure how subjects inhibit food. Participants in the evening study showed a larger hunger levels than those who took the study in the morning, but this did not impact N2 amplitudes. Lastly, researchers controlled for certain variables, including BMI. A limitation was that they did not examine how neural signals of inhibitory control directly related to BMI and should be focused on in future studies.